Hey guys, this is section 4 and 5 in chapter 15, and we're talking about star systems and galaxies here. Star systems, what are they? They are stars here that you can see. Sometimes we have two stars and sometimes we have one star, like ours, the sun. Most stars are members of groups of two or more stars, and they're called star systems. The star systems with two stars, like this one here, which might be viewed as this from the surface of a planet, would be called a binary system. And when one star blocks another, the light from the other star is called an eclipsing binary, just like if we had an eclipse with the moon in front of the sun. Galaxies. A galaxy is a huge group of single stars, star systems, star clusters, dust, and gas bound together by gravity. And there are billions of galaxies in the universe. But each galaxy has billions or even trillions of stars. So our galaxy is the Milky Way galaxy, and if this were our Milky Way galaxy, each one of these little tiny stars represents a solar system. So you can see how small we are in comparison. There are even objects called quasars, which are young galaxies with black holes in the center. Like that's actually what this one is picturing here. And as gases get sucked into the black hole, they heat up and they shine. They make this bright light that they can see with things like our Hubble telescope. There are different types of classification for galaxies. We have this one here. You can see kind of how it looks like it's spiraling down like a drain. That's a spiral galaxy. This is an irregular galaxy because it's just a blob or a cluster of stars. And this would be considered an elliptical galaxy because it looks somewhat spherical. So we are in this Milky Way galaxy, like I said, and if you looked at it from a side view, it would look like this with a bulge in the middle. This would be the location of our sun, our solar system, in these billions and trillions of stars. The top view, if we're looking at bird's eye view, we would see this white, bright light here in the center. That would be the bulge over here, and this would be our location in one of the spirals coming on out. And these are the distance or the size in diameter of our spiral galaxy. The Milky Way galaxy is about 100,000 light years. Okay, scientific notation. I know it's probably something you guys have dealt with in math, but you need to know this just because the numbers are so big when we talk about astronomy that you have to use scientific notation, otherwise it gets out of control. So if we were talking about going, 3,230 light years from Earth, and we want to express that in a scientific notation, we are going to insert the decimal point here between the 3 and the 2, and then multiply that by 3 because we went from out here where this 0 is, and we moved it over 1, 2, 3 spots. So we always use this number here. This number here has to be greater than 0 and less than 10, and then this number up here, the superscript up here, is telling us how many times did we have to move our decimal. Hopefully that makes sense. Let's look at this one. If we have 220 million years to revolve once around the center of the galaxy, the sun takes that long, then express the length of time in scientific notation. So we have to make this again between 0, greater than 0, less than 9. So that means our decimal has to land up right here. So it's 2.2. So to get to there, we would have to go 1, 2, 3, 4, 5, 6, 7, 8. So 2.2 times 10 to the 8 years. Now, talking about the expanding universe, the astronomers theorize that the universe is about 13.7 billion years old. This is the Big Bang theory. And according to the theory, remember, a theory means that we have a lot of information leading us to believe that this is the truth, but it's not a lot. It's not something that we can say for sure this is exactly what happened. So it formed in an instant and billions of years ago in an enormous explosion, and this would be our time lapse. So if this is what happened here, we show up like way over here in the tiny corner. Okay. All of the distant galaxies astronomers have observed are moving rapidly away from each other, so they're expanding. It can be thought of like this. You have these raisins here, and as this bread expands, these little raisins are going to be getting further and further apart from each other. We have something called cosmic background radiation. And in 1965, so this is fairly new, they accidentally detected a faint radiation on their radio telescope. And that glow was coming from all directions in space. So they concluded that this glow, called cosmic background, radiation is a leftover from energy from the Big Bang. Formation of solar system. So the solar system formed from a collapsing cloud of gas and dust. This is how we think solar systems are forming. That includes the sun, the planets, the belts of rock, ice, dust. Everything within our solar system is because of collapsing cloud of gas and dust. So now new observation leads astronomers to believe that the universe is going to expand forever, because when we Rubin here, this astronomer here, he discovered that the matter that we see, the stars and nebulas, etc., only takes up about 10% of the mass in the galaxy. So most of the matter in space is called dark matter, which that can't be seen, and it doesn't give off any electromagnetic radiation. So no waves, right? The expansion of the universe seems to be accelerating, so astronomers infer that a new force called dark energy is actually driving this acceleration. And that's it.